is not the world. The world is much bigger and much stranger. poster on the wall. We stare at it and we think that's the whole world. The room and the poster. But it's all a lie. Something to distract us from the truth. They're lying to us. We're lying to ourselves. The room's not the world. The world is much bigger and much stranger. Safe in that room.
And there's no objection.
Well, that's good. So, okay, this is a little bit odd. Oh, the audio is a little bit distorted. Well, that's good. So, okay, this is a little bit odd. Okay, this is better now. Oh, the audio is a little bit distorted. Oh, that's good. Okay, that hopefully should be better. I might have been getting feedback from my own speaker there, so. So, pre-show banter. Got some pre-show banter going on here. Suppose I can turn the music up. pre-show banter. Got some pre-show banter going on here. Suppose I can turn.
I wonder how many mailing list processing softwares have gotten confused just because somebody emailed about it.
I'm going to test it out here.
So before I forget, how are we gonna handle like the 101 deck and stuff? Since I've volunteered to do that, are we sharing from my screen or?
Stand by. Let me.
Yeah, you have echo.
It's much better now. Sorry, I was trying to get audio to work on the stream. What had happened was I just upgraded and then it got lost, and it lost what audio device it was supposed to listen to, and so I wasn't getting audio through it. Sorry.
Gotcha. No, you're fine. I had that same like internal debate earlier today, like, ooh, patches, right? Should I do that now or should I wait until after the meeting?
Okay. Kayla, go ahead. You should be a co-host now, and you should be able to share your screen.
Okay, so let's fire up the keynote. Share the screen and share. So there we go. How's that look for y'all?
Looks great.
Good deal. Good deal. So
The amount of lag for YouTube just kills me.
Is that like a general statement, or?
No, I'm just watching.
Yeah, I know. I'm playing. What is it, like 32 seconds or something like that?
It's something ridiculous like that. I'm watching the chat and they're like reacting to things. And I'm like, wait, oh yeah, that's right.
yeah.
Maybe we should start hosting our meetings on Twitch.
There we go.
I'm not against that.
Damn it. It was a joke, but
I mean,
they're all getting pretty equally bad. I mean, it's just that I think YouTube has hit the shark fin, of popularity and is on its way down. I think Twitch is getting there.
Yeah. Oh yeah. Oh yeah, that one last thing I need to do because.
Oh, bummer, my special light's not working.
can I put you on the spot, Caleb?
Go ahead.
Can I give you some links to put in there for the DJs tonight?
Yeah, we're gonna update it live.
Fuck yeah. Hold up. I'll throw them to you in Discord.
All right, perfect.
We'll do it live. I saw somebody on Twitter asking about that. They're like, I'm usually updating my slides while I'm walking up to the podium. Anybody else just wait that long?
I've never done the news in advance.
I don't think it would be nearly as good if you did.
It adds a little bit of je ne sais quoi.
Precisely. But it's part of what makes it so good is just.
Yes. All right, so
There's one of them.
There's a second one. Hold on. And I think I'm gonna not tonight. So, as it turns out, I totally still drove here from Columbia today. Son of a bitch.
What were you doing in Columbia?
So I did have a meeting there that I needed to be in person for today, and we scheduled it for today because, see, they asked me 3 months ago, hey, do you want to teach in person next semester? And I said, yeah, that sounds like a safe thing to do. Fuck me, right?
Right.
So I can't take that back, but long story short, yeah, I'm going in on Tuesdays this semester from 9. The lecture will be from 9 a.m. to 12:15. Those poor bastards. They knew what they signed up for. So,
oh dear.
But yeah, I don't know. I was really excited to teach in person again, but now I'm not.
Yeah,
So.
I can understand that. I am terrified for the youth, though.
Well, and I've already, I mean, my youngest sister is a senior in high school, so she's gonna bring the fucking plague here at some point, no matter what. I mean,
Yeah, I'm sure that is true.
Luckily, I just, stay in the man cave, aka my mom's basement. Actually, I'm on the deed now, so technically it's also my basement, but it's much less funny to put it that way. So
Right.
Until she moves out, it's what's up? It's your boy coming from his mom's basement.
Absolutely.
Because that's the funniest shit ever. I mean,
Right. That's the only fun way to do it.
Yeah, absolutely. All right, there we go. Let's see, just gonna run through this, make sure it works, make sure it looks okay for y'all. Yada da da da.
see, Kayla likes everyone. I don't give a fuck if it looks good for any of y'all.
Well, mostly so that I can, give proper credit to our DJ fiends. So
Yeah.
All right. All right. Yay. It works. And we've got 6 minutes till we go live, so, or until.
Till we go liver.
Yeah, till we go liver. Fuck it, we'll do it liver.
All right. I can't get past thinking about the old MAAS screensaver every time you change slides.
Yeah.
Just always turning right. Every time, turn right.
Yeah.
Reed's all up in the Discord comparing me to Will Ferrell. I am flattered. Flattered. It's funny. I feel bad because I know that swearing does make my mom feel uncomfortable because she's kind of a good Christian lady. So it's very sweet. Like now I have to be like, hey mom, we're doing the thing tonight. So there's gonna be 10 minutes of me just really going off. And
oh man. Your poor mom.
I know, right? She's just it's where I get it from. It's just, see, I'm lazy, she's just selling it to me because it's selling the house to me because it's the easiest thing. She'd get more money if she put it on the market, but this is way fucking easier.
Yeah.
Yeah.
Did you get your baseball shirt already, Ben?
I have not yet, but when I get mine, I will grab yours. If you have, or if you get yours first, then grab mine.
There is a possibility I might, I guess.
I know the audio is working because they're still going off on the basement jokes.
Good.
Yeah, on the YouTube channel, yeah.
Y'all are just fucking jealous.
Who's got my baseball shirt?
Probably Patrick still, assuming, yeah. I mean, or did somebody pick it up for you?
Yeah, I would expect.
No, other Patrick, Jiggle Billy.
Yeah, Jiggabelly. Sorry, did I say P chord? No.
You
But-
weren't wrong. You know, they're both Patricks.
Right. And they're basically the same.
More or less, yeah. I mean, I wouldn't say it's like Lauren and Julie levels of the same, but that's like The Office. It's the same picture level, the same.
Yeah. But no. Can I just say I have missed y'all?
I miss interacting with people safe. I miss having the option.
I miss
to interact
people.
with people safely.
It's not that I want to interact with people, but I like to have the option that I could.
Yeah, I'm just like my fucking
Amen
cats.
to that.
Is my audio okay?
Yeah.
Yep, you're good.
You're good.
I can get a better microphone. I just didn't know if this was.
That is wholly adequate.
Okay.
My audio exists, and I don't care enough to find a better mic than what's built into the iMac. So
There you go. That's what I'm talking about. Don't care. Just stop caring. Life gets so much easier if you just stop giving a shit.
yeah.
Let me try the blue ice. I gotta go grab my damn USB-C adapter.
He's got balls and dongles.
Balls.
Well, okay, one ball and a dongle.
Angry balls.
A snowball and a dongle. That is the name of that mic, right? I think
Blue Snowball, I think so. Yeah.
I'm a 14-year-old child.
That's okay. I still snigger every time I say dongle.
Mm-hmm.
You have to. Oh,
Ben,
and,
you drinking that 90 proof vodka on the rocks?
No, this is gin and tonic tonight.
Ooh, Joel's fancy. He's got that Stella Artois.
Yeah, that's so I went over to a friend's house for New Year's, and I was like, better see what they got before I bring in something. So I went in there, and they already had something, so it just kind of got left in my car, and I was like, well, I got some beer. It's SecKC. All right, 2 + 2.
There you go. Now you just need pizza.
My New Year's resolutions did not involve pizza.
That's good, I think.
All right, it's 7 o'clock. Let's get this party started. So, good evening, everyone. Welcome to SecKC. I'm Kayla. I'm going to be your MC tonight. And we're going to go over some rules real quick. So, things you ought to know about SecKC. We are the biggest and bestest monthly InfoSec event in the world. Second Tuesday of every month, somewhere. It says 6 Central, we're doing 7. It doesn't really matter. All right, meetings are unrated. So we say fuck a lot around here. If you got a problem with it, I'm sorry, I guess. All right, so we are celebrating 10 years of SecKC. So 10 years of this madness, 10 years of the chaos. All right, SecKC Code of Conduct. Look for the people listed here. Obviously, this is on Discord. If you're on Discord, look for the people listed under Code of Conduct. If you've got a problem with anyone, folks are harassing, talk to them, they will deal with it. So other things, we have feds in the audience. So we don't keep any member lists. We don't keep any list of attendees, but don't do anything illegal. We really don't like getting arrested. Destroy no data, maintain no persistence, and do no harm. Pranks are fun, pranks are good, but don't do anything that will actually hurt anyone. So challenge ideas, not people. So that's just it. Everyone's approachable. We're all mostly friendly. Make some friends, have fun. And everyone belongs here. Assume all the humans are technical, you know. So, all right, we don't have an STFU wall, but please mute your mic if you're on the Zoom and not in the talk. We want to hear the talks. Go buy the swag, buy all the swag. Just do it. SecKC.org/products. And come visit us between meetings. If you're watching the webcast and you don't have Discord, SecKC.org/connect. Come join us. Immerse yourself. And be the change you want to see. Volunteer. We need volunteers. We like volunteers. We encourage volunteering. So SecKC.org/volunteer. And then of course at sec_KC and hashtag SecKC on all the things. All right, so getting down to the important part. Here's our agenda for tonight. SecKC 101, here we are. 7:15, Aaron's going to take over. We've got Metal as a Service from asmodianx coming up at 7:45. Network Geek's going to give us a nice intro to badge life, and 10 o'clock log off and go to bed. Live tunes tonight. We have Johnny 5 and Codex Mafia providing tunes. Please tune into the streams. Enjoy, rock out, piss your neighbors off. All right.
I think
Welcome to SecKC.
I think Codex has a recording up, but Johnny is streaming live.
Okay.
I forgot to mention that. That's my bad.
No worries. So, alrighty. And I'm going to stop the share and pass it off.
Host has disabled sharing.
Stand by. Preparing to work magic.
Please
Working
bless
magic.
me, God Emperor. The spice can flow. Wonderful. All right. I'll just keep that up till 7. We got 10 minutes. You got 10 minutes to go pull up, go smoke up, go do what it is you do. Mingle. Do we have people saying, don't people usually check chats and shit? Is that how? Maybe we really should do this shit on Twitch. I really fucking hate that that this is becoming maybe a good idea. But
Well,
Six of
wherever
this,
we
half
do it, we're
dozen of
always
the other.
going to have chat all over the place.
Oh, yeah.
well, yeah, but then at least, if we've got, somewhere where it's not lagging and people can, isn't that what, I'm not
Lagging.
I'm not a
Embrace
youth
the lag.
anymore.
Embrace the lag.
Embrace the lag. All right. Well, we got. Yeah. We'll have to have.
So I'm playing a little bit of music in the background while we're waiting.
Okay. Cool.
We all feel safe in that room. It's just that
Or we can continue on banter, or
You know, I gotta save these dulcet tones for the news.
Dulcet tones? I thought it's you yelling and screaming fuck for 15 minutes.
Oh well, you know. See, they give us 1.5x comp time. So if we gotta work at a dumb moment, you know, for some odd reason. Yeah, once everything's back in the green, we get 1.5x time. That was, I got like 2 weeks off there around Christmas. It was a beautiful thing.
yeah, it was all right. I mean, we got comped, but it was just.
I mean, I worked Christmas Day because I work in a SOC. And it was like, am I going to take that sweet, sweet double time? Hell yes.
Right.
I mean, yeah.
So, yeah, had the work laptop in the kitchen while cooking Christmas dinner.
That sounds
It's the best kind of double dipping.
Yep.
Really was. Made a good Christmas dinner too, but did a bison prime rib.
Too rich for my blood.
Yeah, did that, homemade mac and cheese and some vegetables and stuff. But
Shot a duck with a BB gun. No, not really.
yeah, I don't know. Duck sounds really good right now.
I've only had it once. It was oily as shit.
Yeah, it's a
Yeah,
little bit
duck
oily.
and goose both are pretty greasy.
Stare at it and we think that's the whole world.
But I mean, I think I'm fortunate, and I think a lot of the larger orgs are fortunate in that, you know, we have all of our support teams who are all over getting everything patched. So I think we're good, but I feel for the small orgs that are still struggling to figure out what's broken.
Yeah, it's. I think we're going to be seeing fallout from this for quite a while yet.
Yeah, somebody mentioned the other day, this is going to have a long tail.
Much stranger.
Yeah, this is going to be one of those things that just shows up in weird places occasionally.
Yeah. No, my favorite take out of this are the people who are going, oh yeah, we're just using log4j 1 point whatever.
Oh yeah, absolutely.
And it's like, no, it hasn't been confirmed in it, but it's broken in infinitely other ways.
Yep. Lots of shaking of the head over that one. But we get the same thing, right? No, we're totally fine. We use log4j 1.12. Oh, good. That's helpful.
I feel like it's the effect of just like anytime you got a lot of really smart or really clever or really development focused eyes on one particular vulnerability, that entire piece of software gets ripped apart in the following months, and that happened here too.
Yep.
It's just crazy that it was that ubiquitous in its use. Like it's everywhere because it's everywhere. You know, people are gonna start targeting, you know, those kinds of pieces of software.
Yeah, I think you're exactly right. I think we're just going to see more eyes looking for things similar to, but not exactly this.
Yeah.
It's going to open up a whole new avenue.
Yep. It's an interesting time, I think.
I get my hopes up. So many times.
I mean, this is about to throw out a very cold take here, but to me, it's just proof that anything that even remotely touches Java is hot garbage because Java.
To the business of flying the plane or running the program, you kind of forget what you're supposed to be doing because it's done so much for you.
To me, it's why you see so many really nasty accidents on four-wheelers instead of dirt bikes, because the barrier to entry is so low for a four-wheeler. It allows you to be really stupid really quickly. Whereas with a dirt bike, you at least have to learn how to balance and things like that, which is a strange analogy, but I'm going to run with it.
All right. We're about ready here.
Yeah, I know it. You know, I'm a stickler for time. I appreciated Kayla starting like right on time, like snap. Soon as it turns 7, she's on it.
Hey, you gotta roll.
The show must go on.
It's that last minute's always the longest. You're waiting there. You're waiting for that. All right, cool. We're good. All right. So it is 7:15. Let's get started. Welcome to the Open Source Intel Brief, the very first one of the year. Let's see if I still remember how to do this. So if you've never joined us before and you've never seen what this is a news recap. We're using the term news here kind of lightly, or recap maybe. I'm not sure. We do this in a very interesting way. Shouts out to Fitness Chicken. I always forget what his real name is, but his cool name is Fitness Chicken. For originally coming up with the idea of doing the news in this Ignite format. We used to do it where we actually tried to like teach you something and like, you know, make you aware of something. That was boring shit. This is way more interesting. Now, on the off chance that you actually came here to learn, well, you should stay for the talks because they're going to do a much better job of facilitating that. I'm just here to be loud for a little bit. But if you actually want to read about anything that you hear me swearing about over the next 10 minutes, join the Discord. If you haven't joined the Discord yet, you're fucking up. Do that. We have a news links channel. You can check that out. I am sysaaron. I'm also ironically on Code of Conduct. How does that work? It's because swearing isn't necessarily
It's not a bad thing, right? Anyway, look for a text file from me. I'm going to give you what those are, and read the fucking news. See RTFN. You like what I did there? I thought that was kind of clever. All right, that's the extent of my untimed stuff. So, all right, here we go. What would you do if I just fucking sat here for 10 minutes with this slide up? Because I could, just so we're all clear. Yeah, I don't even really need to say anything about this. All right, let's start with data breaches. Cox Communication had a breach. But they promised nothing ever happened with your data. What did they get from you, though? They got your account, your name, address, telephone number, Cox account number, Cox.net, email address, username, PIN code, account security, question and answer, and or the types of services you use. Mon Health had 339,000 records stolen. That had plan, medical number, medical record number, dates of service, provider names, clinical information, medical information, blah, blah, blah. BioPlus had 350,000 stolen. They had a bunch of other shit. Social security numbers were in the BioPlus one. That's terrible stuff. Really? 15 seconds hasn't passed yet? I am skeptical that was all right. Whatever. Morgan Supply on Demand. You've got that thing happen. This was a misconfigured Amazon S3 bucket. We had 100 gigabytes of information, signatures, full names, attachments, phone numbers, goods ordered, cargo damages, processed photos. Fuck. Pulse TV had 200,000 or so credit cards compromised. This was really interesting because Visa told them, "Hey, we think people are using stolen credit cards and getting from there." They're like, "No, that's fine." Then the FBI said, "No, seriously, it's fucking coming from there." And then they were like, "Oh, okay." McNeiman's is a restaurant chain. I don't know. They had, wait, what is happening? That was 1 second. Flexbooker got compromised as well. I don't know what's happening anymore. 3.7 million users compromised there. That was another AWS. That was a compromised AWS account, not an unsecured bucket on that one. So that was interesting. UKG is the group that does Kronos. They got ransomed. They have been down for like, 2 or 3 weeks now. Still no word if they're back yet. I'm not sure if they are. They recommended that you look for other services. Kind of damning. That is unfortunate. So yeah, if you use Kronos, sucks to be you. Look around. Fertility Centers of Illinois got co-opted as well. 80,000 people records compromised their patient names, social security numbers, credit and debit card details, diagnosis and treatment reports, medication, prescription, bank account details, fucking passport information. Why is that in there? Other stuff too. Let's see. We've got a blog post here on the failures of one-time pins. So 2FA, it's great, right? It's perfect, right? No, it's not perfect. FIDO U2F is the best. OTP better than nothing, but has a lot of failures. Go read that paper if you want to see that quantified. Exactly how much of a failure is it? We can see from this paper here, actually. So phishing as a service, there are 1,220 man-in-the-middling packages that support taking OTP codes and relaying those back. So it's a thing, all right? Trust me on that. Let's see. We had some Windows bugs. First time that's ever happened. These were both patched in November, but started getting exploited in December. Basically allows you to escalate to domain admin from just a regular user. So make sure your shit's patched as usual. COVID testing, that is a thing that is happening still. F-Secure figured out that there was a way that you could fool the results of a certain COVID test, a Bluetooth-enabled COVID test that would allow you to falsely submit information to like health officials, blah, blah, blah. Look at that. Let's see. There was a backdoor in the United States Commission on International Religious Freedom that allowed attackers to intercept and likely exfiltrate all local network traffic on the agency's systems. Avast found this, and Avast couldn't contact anyone, so they just published the information. We got some metal detectors that were fucked up. The Garrett IC module. An attacker can manipulate this model to remotely monitor statistics on the metal detector, such as whether or not the alarm has been triggered, how many people have gone through, the sensitivity of the monitor. That is absolutely terrifying. We had a study showing that a lot of apps that are utilized in K through 12 schools are pretty unsecure and also do a lot of unnecessary data sharing. About 13% of these apps sent data to Facebook. 60% of them sent student data to, quote, a variety of third parties. Google's Project Zero analyzed NSO Group's Pegasus malware. So that's something that we've talked about a couple of times. They call it the most technically sophisticated exploit that they have ever seen. They do a technical deep dive on it. You can read that paper. It's interesting. We've got ransomware that was discovered, purportedly the first one to be written in the Rust programming language. People are calling it Noberus, but also calling it Black Cat. I think Black Cat is cooler because it's got this cute picture of a cat, and I think it's a very catchy name. But yeah, it was written in Rust. Hey, you know what works with Apple HomeKit? Hacking, apparently. So this is a bug that was reported back in August, but still hasn't been patched. So this dude publicly disclosed it. Long story short, if you name something in HomeKit really long, you can cause a denial of service condition on iPhones. The police are warning that they have discovered bogus QR codes that are stuck on parking meters in both Austin, Texas, as well as San Diego. I didn't take good notes. But in neither of those cases are you supposed to use a QR code to pay for the meter. So think about that whenever you're parking somewhere. The U.S. Police Department was breached by a ransomware gang. However, they figured out that they breached a police department. And they were like, oh, fuck. Here's your decryptor. So that's kind of funny. It'll be interesting to see if they get popped for that. They just said that they do that because it's hard to get taxpayer money. There was a security vulnerability in Uber's infrastructure since 2015 that allowed people to send emails as Uber. It was reported multiple times by multiple people. They didn't fix it. Fuck Uber for multiple reasons, but add this to them on top. No Reboot is a new piece of iOS malware that allows the device to allegedly, it looks like it's shutting down, but it's not. And it uses these 3 services that are on there. Very interesting attack. Theoretic. I mean, I guess the only way that you would then be able to fully shut it down is to let the battery die. The dude who wrote Colors and FakeLib, I think, or something on NPM, decided to flip out and change his code. That has had a whole host of interesting things happen. We will probably have a talk on that in a month or two. We've got a really cool blog post from a dude who did some pen testing on a PBX. PBXs are those things that facilitate internet network calls. Turns out that there was a backdoor baked into a particular popular PBX that they found, and they documented and published the research on. This cat found a SSRF vulnerability in Google Cloud, not once, not twice, but 3 times. The TLDR of that dude's blog post is verify your fixes, also verify the fixes of your fixes, and verify the fixes of your fixes. Yo, dog. We've got a blog post on cache poisoning at scale. So this individual figured out that sending a capitalized host header could have poisoned the cache on a variety of services. From GitHub, they figured out some flaws. They got $7,500 from GitHub. So there's a dude who ended up getting the IP addresses that can deliver SPF authenticated emails on behalf of the Australian Parliament House, the University of Sydney, Mirvac, and 259 other Australian organizations. Check that out. Really cool blog post here using a laser and a 25x microscope to do a speckle pattern analysis. So here we can see a usage of a calculator using some really elementary stuff. Really cool blog post there. Academic paper here on, it's called Obfuscation Revealed, Leveraging Electromagnetic Signals for Obfuscated Malware Classification. Long story short, they basically classify malware by just measuring the EM data that's coming off of the device. The anti-work movement has had a little bit of old school hacker gusto added to it. So various ticket printers that are exposed on the internet, absolutely nothing new, but now being used to promote anti-work propaganda. Cool, awesome, hack the planet. US East 1 went down, I think like 2 or 3 times since we last met. This isn't even from this last fucking year. This is from a 2020 AWS 1 outage. I just think it's a really funny tweet, so I decided to use that for the slide. The Y2K22 bug is something that we probably all know happened with Exchange. SonicWall, I believe, was also affected. This is happening basically to anyone who represents dates using a 32-bit integer. So, haha, it's fucking hilarious. Everything that is old is new. Norton Crypto is now a thing. So it already took all your CPU cycles. Now it's coming for your GPU cycles. A good comment here is Norton is essentially using your computer to run up your electricity bill and then taking a cut. If I do that, I get a RICO charge. Verizon has gotten you enrolled into a data collection program if you happen to be a Verizon customer. So there's an article out on how you can not be enrolled in that. I would encourage you to go check that out if you are a Verizon customer. Canon and a number of other organizations do that really sneaky thing where they're like, oh, this isn't our toner, this isn't our coffee, you can't use it. Well, thanks to the semiconductor shortage, now you have to circumvent those protections. And that sweet, sweet, tasty irony. T-Mobile has decided that they don't like iCloud Private Relay. At least that's according to the findings of 9to5Mac. A comment from a spokesperson from T-Mobile said that that should only affect people with parental controls enabled, but individual testing has found that that is not the case. Who knows if it's intentional or not? The FBI has sent out a warning saying, hey, you shouldn't open or insert USB keys that are sent to you. Apparently, attackers are sending out a decorative gift box containing a fraudulent thank you letter, a counterfeit gift card, and a USB. Again, everything that is old is new. There was a really cool academic paper examining a number of large-scale phishing campaigns across large organizations that corroborates some findings of the past, argues against some findings of the past, and go read the paper. There is a really cool blog post talking about TCP messages and the difference, it's speed. Speed is the reason why it does it. VPNs fake your syntax sometimes. And that, my friends, is the news. I forgot who's next, or what's next, or what the schedule is. Hopefully someone that is smarter than me remembers when's the next act.
You sure you didn't pull something there, Aaron? You might need some ibuprofen.
You
gotta stretch more.
Yeah, it's my background. I'm not really that red in the face.
So let's see here. Looks like I am up at 7:45.
Okay.
So we got a little bit of time here. So in the meanwhile, I'll turn on some music.
I talk amongst yourselves.
Always love the news. Thanks, Aaron.
Thank you. It is my pleasure.
The slides are always hilarious.
I probably spend an unnecessary amount of time making memes occasionally for these slides. The Drake T-Mobile one, I spent an unnecessary amount of time on that.
Anything more than 30 seconds for any of this shit is really...
It's still like 3 times what you get for to actually talk about it.
This is the Metal as a Service on Raspberry Pi.
Wait, are you gonna present to us a video of you presenting?
Live demos are very dangerous.
Please tell me we're gonna get that meta.
Oh, the best part is we're then going to have a recording on YouTube of the video of the recording.
Yes. Is this a problem? Because I can do it live, but I was like, because we were potentially going to be online, and I was just like, I don't want to have to deal with screwing up in the middle of it and having a live demo go wrong, because there's a lot of moving parts to this demo.
No, I feel you.
I've already got OBS. I can just go ahead and record this too, just to get extra meta and stream it.
Hell yes!
Man, but Joel's showing us up now, like he's all like levels of prepared. Like, we, those of us who didn't have time to pre-record.
Not so much. The pre-show audio is pretty forked.
Carl, I'm gonna call you out, dog. You got to test this already on some of my students.
That's true.
You out here fronting. You've been preparing too, son.
Yeah, baited. Listen, stand-up's not really my thing, so if I'm gonna get the laughs, I needed to test my jokes with a different audience.
That is true. That is true.
So you want me to do this live?
No, do whatever you're planning on doing. I don't give a shit.
Oh no, you're
You
fine
gotta
to
do
do
it-
it. It's
do it
not
like-
unprecedented.
Do it like a change in work. Got to do it in production.
Can you make sure your live screen is on so it can have Joel reacts to Joel giving? Isn't that what
That would be
YouTube is
good.
now,
Okay.
basically?
Because there was like, because I was like going through and making it, and then like, oh, I got to rechange it. Oh, well, I figured out a way to record the Raspberry Pi correctly and all that kind of stuff. So I had to record it again, and there was still one more part that I was like, should I reshoot it? I was like, yeah, it covers everything.
We've definitely done pre-recorded before, so totally your call.
All right, the news links are live, you filthy animals.
Hello, this is the Metal as a Service and the Raspberry Pi talk for SecKC, for the SecKC Home Lab series. My name is Joel Kirshner, and I volunteer for SecKC, and I'm a little bit of everything geek. Some of the main topics I want to cover with this talk is use cases for having a home lab, and the Raspberry Pi and some of the key technical improvements that make it possible to make it centrally managed like we need for the Metal as a Service platform, and the UEFI project for Raspberry Pi, which essentially gives it a functioning UEFI firmware interface. And then the Metal as a Service platform itself and kind of how to configure it, and as well as how to spin up a new host. And then we're going to talk about integration with virtualization technologies, as well as post-configuration with CloudEnd. So some of the use cases for a home lab for Metal as a Service, rapid deployment. Virtual machines are fairly quick to spin up by themselves, but actually setting up the operating system is very time consuming because you have to go through a lot of post-configuration steps, and actually waiting for a CD or a virtual CD to actually load the operating system usually takes a long time. Asset management is if you have a large number of, or a combination of both Raspberry Pis or computers, Intel NUCs, laptops, or anything of the sort, it's kind of hard to keep track of what device has what resources. Sometimes you find yourself having to open up a computer just to see how much RAM you put into it and what size of hard drive. And then centrally managing the network and storage configuration at setup time for these devices, as well as manipulating the DNS records so you can access it without having to memorize large numbers of IP addresses. So, what is Metal as a Service, and what is it not? So, Metal as a Service is not really a virtual machine. It is a tool for controlling a large number of physical machines or virtual machines if you happen to have them using the network. So it's really intended for high-end Intel servers that have integrated lights out functionality, as well as the ability to use a PCB bootloader. Most end-user low-end hardware supports PCB booting on physical network interfaces, but not on Wi-Fi or anything like that. Also, single board computers typically don't support PCB bootloading, and so that makes it very difficult to make use of those in your home project. And so consumer grade VMware, Proxmox, and LXD power and chassis support is available, but it's really more focused on the expensive chassis and larger paid-for versions of VMware and all that, because it's the support is really kind of clunky at best. So it's possible, and you can potentially do it, but there's a lot of effort into getting it up and going and working. And then low-end device power control is going to be clunky because of this, and it requires a lot of manual poking of the power button and key mashing to get this to work right. So it is faster to use Metal as a Service, but there's some of the automation isn't quite there yet. The Raspberry Pi 4 is probably one of the bigger, faster single board computers that is kind of in the community today. I mean, I think everybody I know has some type of fixation of buying the latest, greatest new version of Raspberry Pi. So most of you will have one of these lying around your house. The Raspberry Pi 4 comes in several different flavors. You have the 2 gig version, the 4 gig version, and the 8 gig version. And it features ECC RAM, which means the RAM is resistant to random bit flips due to cosmic radiation or anything like that. USB 3 support allows you to attach external drives, and it will allow you to run a much faster machine. Just relying off of the SD card or some type of USB 2 device in the past has just been, it really makes making a working server out of a Raspberry Pi very difficult when you don't have that kind of bus speed. The Ethernet adapter, it supports a very rudimentary form of network booting, but it is a full 1 gig Ethernet adapter. So in the past, in the Raspberry Pi 3, it was very limited. It was limited to the USB 2 bus, so up to 600 megabytes per second. This is a full gigabit per second. Bluetooth and 802.11 ABGN Wi-Fi, and there's some hacks available to allow you to use monitoring mode, which is useful for any type of home monitoring or any type of advanced Wi-Fi projects. And I mentioned the boot PROM, and it has a quad-core CPU, so it allows you to run a lot of software very quickly. Cost effectiveness is hit or miss. The lower cost per unit is also, very, it's very attractive. So just per device, it's much less expensive than purchasing a Intel equivalent. The power efficiency is much better than Intel's low-end Celerons, so significantly better. But there's higher technical complexity because it's not really meant to be an end-user device. It's meant to be used for projects, and it's an open-source device, so there's a lot of kludges and hacks that have to be implemented in order to get this to be useful for more mainstream uses. And then there's missing functionality. There's no power button, the upgradability, it's everything soldered on the board. There's no real-time clock that will survive a reboot, I should say, and the non-standard bootloaders. And so those kind of are detractors from wanting to use the Raspberry Pi. But really the big selling point is power consumption. And it's going to be an even bigger point as time goes on because our power grid is becoming more stressed because of our reliance on electricity for heating and everyday activities. So a typical computer running at 100 watts will cost you about $105 a year if you're running at 24/7. If you're running a laptop, usually that's between 50 and 65 watts, and it's going to run you around $50 a year if you run it all day long. And then yearly power consumption of a Raspberry Pi is between $5 and $15. So that's a big difference. So the money that you save up front is also, you save even more money in the long run because you're saving lots of money on your electric bill. The Raspberry Pi UEFI project, it loads all the binary blobs and all the things that the Raspberry Pi needs to load in order to boot properly. It doesn't have to pull it over the network. It's all loaded on the device itself. And it provides all the features that a UEFI firmware provides, which is the ability to do a full Pixie boot and configuration of a lot of the hardware things. So one of the things that it helps with is that it has a bug fix, so that in order to run a Raspberry Pi and run it with more than 3 gigs of RAM, there's a bug in how the hardware is set up, and so you have to use a very, very recent edge kernel in order to get a Raspberry Pi to boot correctly and make access of all that 8 gig or 4 gig of RAM. So you can so there's a bug fix in there that stops it from using anything more than 3 gig. You'll need to disable that before you can make use of that, and you need to make sure if you are going to use more than 3 gig of RAM, you need to make sure that you're using a brand new kernel to make that happen. Metal as a service, this is a means of programmatically controlling a computer, specifically a server chassis with lights out management. So what this means is that you are able to manipulate a physical server kind of like you would a virtual server. You can tell it to boot up remotely without touching the power buttons. You can tell it to display the screen, all kinds of stuff. So this makes use of that functionality in server grade technology. Rapid deployment of Linux OS and other OSs with the canonical tools. So by default, it only allows you to use Ubuntu Linux and CentOS. But if you get their special software package, you can potentially wrap your own distros into it. And so you can make use of a lot of the bundled cloud OSs that you can use with cloud services, and you can actually push that out to physical hardware if you need to. So that's a feature of actually paying for the Metal as a Service premium package through Canonical. You can potentially do it on your own and kind of hack your way through it. It's just difficult, and they make it difficult. They want you to pay for the service. It's scalable, easy to control an entire data center. This allows you to hook into a blade chassis system, and you can hook it into a virtual host system like VMware or something like that. So I'm going to walk you through the complete setup of Metal as a Service, and then go through how to set up a virtual machine with MAAS, as well as setting up a Raspberry Pi. Okay, so I'm going to start by installing the Ubuntu Snap for the Metal as a Service. And once that loads here, you should see a bar start spinning once it's ready. I need to use the stable repository for that. So it'll go out and get all the things it needs. It's pretty quick. The next step after this is that we need to load the database. So there's a couple different ways you can do the database. If you're doing a small installation, then just using the prepackaged Snap for the test DB works great. If you're trying to run a large data center, then you need to scale up the database server and manually load the database and actually scale it out, give it more RAM, etc. Now we're doing the setup command to set it up as both in region and rack mode, and I'll get more into detail on this. Region is for controlling a data center, and rack is controlling a grouping of physical servers, and so inside of a rack. And then I'm setting up the database URL that it knows where to connect to actually write to the database. It'll go do its thing here. And then the next step is we're going to create the local admin account for the web service. You can name the account anything you'd like. I just used admin. Put in a password that's secure and an email address in case I forget my password. Though you need to have your email server running in order for that to work. Now you can add in your SSH keys here if you'd like, or you can do it as, later in the setup process. So everything should be running right now, but the next step is to check to see what services are running. Make sure it didn't have any problems when installing. So MAAS status, and it tells you what services are running. The DHCP servers need to be configured before they'll start. So you connect to the IP address of the machine you installed MAAS on, and it's port 5240, I believe. Yes. Put in the username and password that we created. Okay, it's telling us that it has not imported the disk images yet, but we'll deal with that here in a little bit. We need to set up the connectivity, so set up the DNS servers. DNS servers, you need to potentially give permission for another internal DNS server, like your home router or something like that, to contact the Metal as a Service DNS server. And once you do that, then all of the DNS names that you create in Metal as a Service will be usable on your entire network. I'm clicking the ARM64 platform, so it downloads those disk images as well. Check here, see if there's anything else I want. Nope. Go ahead and continue. And it'll start syncing all the disk images from the internet. So you do need internet access for this to work. So then we'll move on to installing the SSH keys. If you didn't do it earlier, you can do it now. And just copy and paste in the public key. Finish the setup. It should be up and going now. The next thing we want to do is configure networking so we can get the physical and virtual machines booting. It should fill in the details of what it knows about the network you're on. And then you go into the VLAN or the untagged link there, and it'll give you the option to actually set up DHCP. Next step, we go into VMware, and I set up a new virtual machine. Set up to be a Linux VM. In this case, when it's set up to be a Ubuntu Linux VM, doesn't really matter what I name it, because Metal as a Service will give it a generic host name. In this case, we need to have at least 2 gigs of RAM in order for this to work. And then I need to make sure it's set up on the correct network. And so, in this case, it's VLAN 202. So I start up the machine. And it goes through and it's able to reach out using the PXE boot process, and it starts booting. Now, inside of the MAAS console, you should see it commissioning. And then as it goes through each phase, it'll kind of give you an update there. One of the things you need to do is once it shows up in the Metal as a Service interface, you need to set up the power type. And so if you don't have some type of power control or chassis control, then set it up as manual. Once that's done, we need to go back and make sure that it's done. And so we look at the virtual machine, and it should be almost there, and now it's done. So it gives it the status of new, and then I want to go and commission it. So commissioning just goes through, once we have the power configured, we have the ability to figure out what's on the machine. So it kind of gives it a first initial once over, and then once you give it the power configuration, then it'll go through and allow you to work on the new machine. So it's going through the testing process, and it goes through a large list of tests looking for hardware problems and anything like that. Every once in a while we'll find a problem with the smart configuration. Sometimes you just need to run it several times over to get it to resolve that. You can also ignore any type of smart errors with hard drives. So we take a look here at the file systems. You can potentially add or change or remove file systems from the configuration here, manipulate the partition setup and all that. Now we're going to go to deploy, and we need to make sure that we have the newest kernel. In this case, I'm using the Edge kernel. I have the choice at this point to set it up as a KVM host for virtualization. I don't want to do that. KVM on Intels is probably the most effective way to set up a virtual machine using this. The LXD isn't quite that stable yet, so it's going through its setup. It's deploying. Going through its deployment process. And then it'll go through and reboot. Now, how to access this machine after you've created it. It's been preloaded once it goes through its post configuration with your SSH key. And you know the IP address it gets from the MAAS console. And so you can see on the right, I have the console there. I go ahead and connect using the SSH key, and it lets me right in. Take a look at HTOP and one CPU. All right, now we're going to go into setting up the Raspberry Pi. So this is the Raspberry Pi bootloader. This is booting up the boot firmware, and this is the Raspberry Pi UEFI. Hit escape to go into this control menu, and we're going to go through, and we need to go through and set up the Raspberry Pi configuration, and then we need to go through to the advanced configuration and disable, make sure that the limit is disabled so you can access all of the RAM. Make sure you save it. And then we need to go back. And then we need to go through and we need to change the boot order. You can see the boot order here, and then hit enter to go ahead and edit it. And they use the plus and minus to move stuff around. And I'm going to move Pixie boot for IPv4 to the top. And save that. Then back out of that. And then we need to potentially reset this in order to load the new configuration. Once we do that, it will show up in Metal as a Service. We need to go through and get rid of the flash drive that I'm using to load the UEFI bootloader. Alternatively, you can either use an SD card for that. It's kind of wasteful, and so you really need to load the most recent firmware image so it's able to boot off of a USB drive. Make sure the Edge kernel is selected there when you're deploying it. And And that should do it. So go back here. And so let's go over the steps that we witnessed there for setting up everything here. Okay, so we installed the Metal as a Service snap, and then we installed the test DB, and then we configured Metal as a Service to be a region and rack controller, and we set it up to use that test DB. And then we created an admin user, and then from there we go through and click on subnets, clicked on the untagged network or the VLAN that you'd like to actually control hosts on, and then go into that and click on Enable DHCP. And then you can click on the Images tab and select Ubuntu 2004 and make sure that you have both the AMD 64 and ARM 64 architecture selected for Ubuntu 2004. Then click on Settings under Configuration and Commissioning and select 2004 and make sure you have the Edge kernel selected as the default kernel to use. When deploying a machine, you PXE boot the device, and then it'll assign a device a random host name, and then you'll configure the power settings. Then you'll need to go through and commission the device again, so that's another reboot. Once you reboot the device and go through the commissioning process, it becomes ready, and then you can modify the network and storage settings inside of Metal as a Service, and then go ahead and tell it to deploy. With deploying a Raspberry Pi, you have a few extra steps. You need to go into the UEFI and disable the 3 gig RAM restriction, and you'll need to have external storage because you need to have a storage device used to actually contain the UEFI bootloader. Then you'll go through, connect to the Metal as a Service network, and then boot it. Once it's booted, configure the power and the name for the machine. Remove the UEFI disk from the configuration because of how MAAS works. Any device, any drive it sees on the Raspberry Pi will potentially be repartitioned and the partition reset. So that'll disable it and keep it from getting rebooted. So you need to remove the UEFI disk, whether it's the SD card or some external USB drive, and remove that from the configuration so it doesn't see it and doesn't try to delete it. And then you tell it to deploy. Once it's deployed, it should perk up and you can access it using SSH. One of the things I recommended earlier, which is installing the Raspbian Linux and upgrading the EEPROM on the Raspberry Pi 4, it's very useful because then you can actually boot off of USB devices instead of just being limited to the SD card. You need to make sure that you install the Raspberry Pi UEFI onto a FAT32 formatted SD card or USB drive, and then attach external storage for the actual operating system to reside on. And then at that point, boot and reconfigure UEFI to PXE boot and disable the 3 gig RAM limit and attach a Raspberry Pi to the network and go over the same steps that we did earlier. Some of the key concepts that we were looking at earlier. The region controller is a server that controls a whole data center. So its job is it has a large database, and then it actually manages all of the rack controllers. And a rack controller is typically a machine that's attached to a rack or a grouping of a specific kind of hardware and kind of network. And then that's how you can deal with large chassis and large rackfuls of different types of hardware, is using a rack controller. And it allows you to scale out to a whole data center. When you're configuring the Metal as a Service platform, you'll have pools and zones, and that helps you group together assets inside of Metal as a Service so that you can load balance So when you're spinning up new hardware, it doesn't just grab all the virtual machines on one virtual host and overload it. You can, if you split up all the virtual machines on all the different virtual hosts, you can actually spread things out evenly across all the machines. And then tagging individual compute resources helps you script things using the API interface. So you can tell a script to say only spin up resources on machines that are tagged with this tag. And so that's something you can do. And this is the installation hierarchy. So as I said, the region controller, and then rack controllers, and then from there, network spaces and subnets and VLANs. Networking, MAAS really needs its own network because it needs to control DHCP. So it's not something that you can spin up on your home network that's set up as a flat network. It really needs to kind of be on its own /24 network and hooked up via router or some type of broadband router to let it have its own domain. You can potentially also use a NAT router, or you can play around with the DHCP server and kind of try to shoehorn the configuration into your own DHCP server, but that's very difficult. Some of the things you will want to watch for when creating multiple networks is routing loops. So you need to make sure you set up static routes on devices that have interfaces on more than one network. When you're configuring networking, you potentially can have different spaces. And so each space may have different conflicting VLAN setups. And because of that, that's why you want to use a separate rack controller and separate spaces. Because, for instance, with VMware doesn't deal with VLANs. It has port groups that are associated with the VLAN. So the host doesn't see tagged traffic. It just knows that it has a virtual NIC attached to a layer 2 switch. It doesn't know that there's tagged traffic going to that switch or port group. So when you have your Metal as a Service server sitting on VMware, it needs to any space that the rack controller talks to needs to have the same type of networking setup, its own space, if that makes sense. So anyway, it's something to be aware of. DNS is a cool feature. So it has its own DNS server, and you can control all the tags and make updates. And so that's one of the big problems of home networking and home labs is that you've created all these resources. Now you got to remember, what servers on what IP address, because there's just not any good DNS tools out there for you to use. So this is a good way to manage the DNS of your project environment. Then, as we saw earlier, using SSH public keys to authenticate to your newly created servers is kind of how you get access to them. You can also use cloud deployment tools such as JUJU, and that's something you can get access to on JAAS.ai, and that URL may change in the future, so they have kind of a reference on that page. But what that does is that you configure it for a cloud service provider or your Metal as a Service environment, and then you can spin up resources. So if you have a bunch of physical machines, you can spin up those physical machines and actually load cloud resources and cloud applications directly to them, and you can actually blend that with EC2 and other cloud service providers. And so you can have kind of a hybrid configuration that way. So Ansible can also be used, as well as any other custom configuration or central management systems, and that can be done using Cloud Init. So LXD containers are supported. It's fairly recent that they've added it. It's kind of clunky. It's good for making a very simple virtual machine very quickly. On Raspberry Pis, you can create virtual machines on a Raspberry Pi, but the catch is that Raspberry Pi doesn't support normal kernel virtualization, and it has kind of a very clunky way of implementing LXDs. It uses fan networks by default, and then that kind of clutters up the Metal as a Service networking list. So it's something to be aware of. Utilizing Proxmox and VMware. As far as setting up creating virtual machines on VMware or Proxmox and then using Metal as a Service to deploy to them, that's very easy. And when you're looking at some of the features, Metal as a Service says, yes, we support VMware, yes, we support Proxmox, all that kind of stuff, but it supports them from a power control standpoint, using it as kind of a virtual chassis, so to be able to turn on or turn off your virtual machines. And this is very clunky. I had to go through a lot of effort that wasn't well documented in order to get VMware to work, ESXi work, and I haven't been able to get this to work consistently. So that's something to be aware of with your low-end VM infrastructures. It's really geared for the high-end stuff, so vCenter and that kind of thing. So be aware with that. I mentioned CloudInt. CloudInt is a way of post-configuring your servers. So either putting in custom configuration into the server or running custom scripts or anything like that. And so it's a industry standard, multi-distribution, and should be pretty easy to get a hold of. So this is an example of that. So when you're deploying, there's a checkbox that says CloudInt user data, and you can add your CloudInt configuration string in there, such as configuring the resolve conf and putting in a very custom DNS setting in this example. There are some gotchas. So, as I said, any disk that Metal as a Service sees in the configuration, it will try to delete it before actually going through and applying your configurations. So that's something you need to, if you have a disk with data or information you don't want it to touch, make sure you just take it out of the configuration so it doesn't touch it. You need to make sure that your machine has more than 1 gig of RAM. Otherwise, the scripts will kind of bomb out and it won't load correctly. You need to make sure you also have very fast storage. So a USB 2 drive will just run too slow. It won't load fast enough and it'll time out and give you errors. And here's some resources for you. The Metal as a Service website, maas.io, and then the GitHub repositories for the UEFI firmware, as well as the Raspberry Pi 4 EEPROM boot firmware, and then information on the CloudInt. And with that, do you have any questions? Thank you very much. Have a great day. All right. So I've been answering a lot of questions in the general Discord channel. And I think we're going to pause here, and unless we want to go ahead with the next talk. Crickets chirping.
I did have a question.
Go ahead.
How do you come up on that topic?
So I was looking around for open source virtualization technologies. Something that really bothered me is that all the open source stuff either was terribly, terribly broken, or it was it didn't work, or something like that. And all the stuff that we were expected to use was this kind of freebie stuff where it was free for personal use, but if I wanted to use it for business, that's a problem. And so also you had the problem of how do you scale that stuff out. Now, this was when I started looking at this was before Proxmox came out. So Proxmox is kind of the open source way of doing virtualization at scale. So I was kind of looking at it from a standpoint of how do I do this? And so it has Linux kernel virtualization built in as a feature. So you can potentially spin up an Intel PC, and you can configure it, do all the networking. And then once it's up and going, you can continue to start spinning up virtual machines on that host. And so you can do your large scale project, in virtualization. So it does virtualization. The frustration point is the development on this is there's parts of it that work well. And then there's parts of it that they either give it almost no attention or just, or nobody's paying attention to it or something like that. So I'll run into weird problems where when I spin up a virtual machine and set up individual drives for it, it will get the drive order, jumbled up. When trying to do LXD on Raspberry Pis, it works, but you got to keep the Pi design, the LXD virtual machine design really, really simple, because by default, in using the current version of LXD and Ubuntu, it doesn't want to add any additional extra drives. So you have to go in and manually update the LXD snap on each of the devices in order for it to work kind of correctly. So there's a lot of little gotchas when trying to use MAAS with virtualization. But I think when you're using just standard PCs, not anything exotic like Raspberry Pi, it works out pretty well. So you can build virtual hosts using standard PCs, and so it's a really cool way to very quickly grow out your infrastructure and then tear it down and rebuild it very quickly.
Yeah, that was a really cool talk. Thank you. I think I might try that.
Any other questions? So, like I said, I've posted the presentation along with the video in both YouTube channel description and as well as our Discord main channel. And by all means, get in touch with me if you need any additional information.
Hey, Joel, it does look like you didn't open up public permissions to that.
Crap.
Just FYI.
Well, isn't that just fun? Let's see here. That should do it. Sorry about that. So, comments? All right. So, I think we have a little bit of time before the next speaker, unless they want to go early.
Whatever we want to do.
I don't see any problems with you going ahead, Carl, so.
All right. So we get my, I don't have a recording. I'm not as prepared as Joel was.
You're going to do it live. You're awesome.
Doing it
I know you can
live.
pull it off.
Yeah.
And I've actually got live demo too. So
Awesome.
we'll see if we're able to pull this off. Let's see if I can figure out Zoom here. See if we can get a little Zoom. No Zoom session. Zoom inception here. Okay. I think we're good. You can guys see my screen?
On Zoom, yes, sir.
All right. Well, we'll jump right in. Thanks everyone for coming tonight. I'm doing the first in a series of talks on building badges. My name's Carl Fugate. I'm part of the Badge Pirate team, along with FG, Rickson, Jigglebilly, P-Cord, and Codex Mafia. You can find all of us on Discord in one channel or another. So, getting started, why should you listen to us? And the reality is you should not. We do not know what we're doing. We've done a few things, but we are not professionals, no matter what Aaron says. We've been making badges since 2017. Our first badge was for SecKC. And we've, in the meantime, managed to cajole and convince people to take a chance with us to try to make some cool things. And we've done a few conferences, and somehow we've now managed to have over 20,000 PCB badges produced in the last 5 years, which is for us is pretty amazing. We did a electronic badge, and we did a Learn to Solder kit for Maker Faire KC back in 2019. That was our first what I would call large scale conference. We did over 4,000 badges for Maker Faire and 500 Learn to Solder kits. It was definitely a stressful project, but incredibly rewarding. But did I mention you really shouldn't listen to us, because we really don't know everything that we're doing. And to prove it, I will introduce you to our first badge. Back in 2017, for DEF CON 25, we decided, Kevin, FG, and Rickson and I got together and decided we wanted to make a badge after seeing all the cool unofficial badges at DEF CON, and we wanted to make one for SecKC. In 45 days, we went from a concept that we presented at a SecKC meeting, and by the next SecKC meeting, we had delivered this badge, and it was just a PCB with a dev board, a SparkFun ESP32 thing dev board with a screen, a couple of buttons, and we had no idea how to actually design any of this stuff, including artwork. So the artwork was spray painted on the board. We laser cut a stencil and airbrushed the artwork onto these badges. It was awesome in its simplicity, and yet, by today's badge standards, absolutely, a kid's drawing with crayon. However, over that few years, we started to learn a thing or two, and for DC27, our unofficial badge for SecKC was kind of record setting. We had almost 650 LEDs on the badge, which had never been done before, as far as we could tell. And we made enough badges that it took us buying over 100,000 LEDs to make them all. It was quite a work of engineering and project management, and long nights and days sitting in a suite in Las Vegas fixing boards that we had messed up, but we got it done. So this talk is about how to get started in making a badge or a PCB. So we're using PCBs, printed circuit boards, as the foundation for making an electronic badge. And this kind of came from the fact that the process for making a printed circuit board is actually relatively inexpensive. Back in the day, compared to the price of stickers, having a PCB made was really not that much different. And that's really kind of where this whole kind of idea of badge life came from, was, we have kind of sticker life, in the InfoSec world and at DEF CON. And this was kind of another way to do it in a cost-effective way. But since then, it's really become an art form. But in order to really kind of understand how to do this, you really kind of need to understand how PCBs are made and how they're put together. PCBs, I think Shrek kind of said it best. PCBs have layers. They're made from a couple of different materials and processes that give us a firm substrate that the board is made of, and some other processes that both give us the electrical conductivity layer that we need, as well as some protection for the board from shorts. This is kind of an example of what this looks like. So a typical PCB is made up of 4 layers. The first is the substrate, or the core of the printed circuit board. This is typically made up using a substance called FR4, which is a fiberglass material. And in and of itself, it has no conductivity whatsoever. As a matter of fact, it's an insulator, which is really what you want. And so what PCB manufacturers then do is they actually adhere a copper layer to that substrate. And that's how we actually get the traces for the conductivity needed for an electronic circuit. But once we have that copper on the board, if something were metal or were to come in contact, or if you were to put a big blob of solder on this, you could very easily bridge some of the traces that could be really close together. And so what they do is they apply what's called a solder mask on top of that copper layer. And the solder mask gives you protection and isolates the copper traces from each other and protects the surface of the board. On top of that solder mask layer, we then can have what's called silkscreen. And this is just like any other traditional printing process. Silkscreen is just ink being laid down on the printed circuit board on top of the solder mask itself. There's really nothing unique about that. And typically in a printed circuit board, that solder mask or that silkscreen is really just there to for reference. So typically you would have if you had a resistor on a board, the resistor would have either a value or maybe an identifier, and the silkscreen would just give you that information on the board as to what this component was in the circuit. But in kind of the artistic world, we've kind of taken this to the next level by taking the substrate layer, the copper layer, the solder mask layer, and the silkscreen, and we can kind of take them and do some really unique things. So if we build these things up, from the bottom, if you look here in this kind of eye, this is actually the substrate, that FR4 kind of coming through. So what we've done is we've not placed anything there. So there is no solder mask to cover up the board. There's no copper underneath it. And so we can actually see that layer. And from a PCB perspective, that gives us a color. right? So this is one color that we get to use in that PCB, or one element that we get to use. So then the black ends up with the solder mask, gives us yet another layer or another color. And so now we have two colors that we can use. The third color comes from the copper itself. So the copper, the processes for how they lay the copper on, there are several different ways, and there's several different finishes that you can get when they put the copper down. There's actually kind of a copperish color that you would kind of what we would typically call a copper color. There's a silver color, which is a solder process where they actually use either a leaded or a non-leaded solder to finish the electrical traces. And then there are some gold, there's a gold finish, which is what was used on this board. And so that gives us our third color. And then obviously the silk screen gives us our fourth color. Now, one of the challenges is that this is not a full printing process. We don't get, an infinite, variety of colors to use from, and there are restrictions. So we have to always remember that these boards were not designed to be art. They were designed to be functional. And so as an example, when we go to look at solder mask and silk screens, there are combinations that we can use. So as an example, if I were to use a white solder mask, the only option that most PCB manufacturers will give me for the silk screen is black, and vice versa. If we use black solder mask, the only option that they will give us for the silk screen color is white. And so it really limits our palette as to how we can design these. So if you've ever looked at, badges that were made by other people or by us, and we're always wondering why the color palette was so limited, this is kind of why. That being said, it's really fascinating because this whole badge life and badge art concept has gotten manufacturers wise, and they've now started to offer more color combinations and more colors. PCBWay most recently offers now what they call an advanced PCB service, and in that they actually will now allow us to do more color combinations than what we would have typically had. And so we actually get the ability with that process to be able to use other silkscreen colors with other solder mask colors. They also give us some additional solder mask or colors such as pink, which we haven't done yet, but I expect that you'll see a badge probably this year with pink. But you're really starting to see a lot of fab houses open up to be able to allow us to use, and be more creative in this process. When I talked about layers in this, we've now kind of seen what makes up a layer. But you also have to kind of think about these in 3 dimensions. So this board is actually what we call a 2-layer board. So we have a copper layer, the solder mask, and silk screen on one side. But if we were to flip it over, we have another side, and we could do the exact same thing. So as long as we have an isolation or an insulation core in that layer, we can stack these. We can stack some of these layers on top of it. In traditional badges, you're going to see a 2-layer board, which is just a front and a back. The process for how we go about creating badges, one is design the artwork. And this is where we struggle a lot. None of us are artists. And that definitely makes things challenging. So if any of you out there in the community are artists and would like to work with us on a badge sometime, we would be happy to take your help. But you first design the artwork, and once you have that, you need to get that artwork into the electronic design automation tool. That is what will actually create the files for the fab house to be able to actually build that printed circuit board. And inside of that EDA tool, that's where you will actually do the electrical design if you're going to put any type of electronics on that PCB. We're going to do a whole nother talk on that because that's going to take a little bit more time, but it's going to be kind of a continuation of this. We're going to see a process that we're using today, or a design that we're going to use today, and we will then add the electronics to it in the next talk, and we will actually have a functional badge at the end of this series. So once you have the artwork done, you have the electrical design done inside of your EDA tool, you then export those files. Those are called Gerber files, and that's what any standard PCB fabrication house is going to want in order to create this. And the Gerber files are just a set of a different set of files that give the fab house the information they need to do each of these steps. So they know which solder finish process that you want to use, and how to lay the copper layer down. They know because that's the first step or the first process they're going to do. Then they will put the solder mask down. That's a whole nother process. Then they will do the silk screen. If there are any drill holes, they will then actually drill them, and there's a drill file to do that. Then there is a routing process, a CNC process to actually cut out the board. So there's another file to be able to do that. This whole process is basically constructed for the fab house via these Gerber files. So once you upload those Gerber files to the manufacturer, you tell them some of the specifications, which we'll go through here in a little bit. You can actually pay them their money. They will get them shipped to you, and you will then have your PCB available to you to actually, if you had an electronic circuit, to place the components on it and finish it up. So PCB tools. So the Badge Pirate team, when we first started this, we used to use a tool called Upverter, which was a web-based EDA tool. The ability to do artwork in that tool was extremely limited, and we quickly outgrew its capabilities. We wanted to, in keeping with the open source spirit, use an open source tool chain for our badges. And we've kept with that to date using this tool chain. It starts with Inkscape. So Inkscape is a vector drawing tool. It's open source, runs on multiple platforms, Windows, Linux, Mac. And this allows us to actually create the artwork for the badge. We also use an open source extension to Inkscape called SVG2Shenzen. And this allows us inside of Inkscape to actually put the artwork in the correct layers that the EDA software can actually import in and build those layers inside of the EDA tool. And we'll show you a little bit how that works. And for the EDA tool, we're using KiCAD. The versions that I'm going to show you today were current when I gave this talk a month ago, but there's now a new version of KiCAD, KiCAD 6. I'm going to show you this in KiCAD 5. There are some ways to do a lot of what we're doing directly inside of KiCAD, especially now with KiCAD 6. However, we've really found that when you're just trying to design the artwork and get these layers in, this process of doing it in Inkscape and using this extension to pull it into KiCAD keeps everything aligned, and it gives you the visualization that you need to understand exactly how this artwork is going to look once it gets into the tool. So when you're designing your artwork, you want to stick to vector formats. That's why we use Inkscape. Vector formats allow you to resize things directly. Vectors are just a set of paths. So unlike raster images like bitmaps or JPEGs or GIFs, you can actually resize things as you need. And this can be really important in PCB design, because getting things lined up and getting that designed, when you go to actually order it, you may want it slightly bigger, or you might want it slightly smaller, depending on what you're trying to accomplish. And so by doing it in vector formats, you're able to resize things as you need them to get them to the final size for your project. A couple of things that are important to note when you're working on artwork for a PCB. One, the solder mask is what we call a negative layer. So all of the other processes, putting down copper, putting down silkscreen, these are additive processes from a manufacturing process. The solder mask layer is also kind of an additive layer, right? They're putting this resin over the top of the copper. But when we build the solder mask layer from an artwork perspective, anything that we place on the solder mask layer is actually removed. So if you were to, if you had a circle and you were to draw another circle, and you, let's say you had one large circle and that was your board outline, and you were to place another smaller circle on the solder mask layer, what would happen is that circle would actually be removed or cut out from the solder mask. And so what would happen is you would be able to see through to the board beneath it. So again, anything that you place on that solder mask layer, it's a negative, versus the other layers where it's a kind of positive layer. What you add there is what you're going to get. Other layers, as I mentioned, they're additive or inclusive layers. They will be put, as you see them on the board. One other thing, when we talked about kind of multi-layer, doing a front and a back, the other thing you need to kind of keep in mind is you're building these together, and while the EDA software is aware of the front and the back, when it's actually showing you these things and when you're actually designing them, it is not automatically reversed. So if you were to place something on the back layer and you didn't reverse it, it's going to come out backwards. So when you're building up your different layers, if you're going to put something on the back, you need to reverse it. So it's going to look backwards in your artwork, but it'll look right when you actually pull it into your EDA tool. One exception to that, which is a trick that we use, is for cutouts. So sometimes we actually want to do things like let light shine through, like we would have an LED on the back of a PCB, and we would want that to shine through to the front of the badge. What we'll do is we'll actually cut out the solder mask on the back side and the front side to let that light come through. And when we do that, you don't need to reverse it, because then it's lined up all the way through the board. Some of the layer information. So we talked about the different layers. They actually have names, and these line up when we start talking about Inkscape and SVG2Shenzen, and we talk about KiCAD. The layer names are kind of as follows. So for the front copper, we have F.cu, which is the periodic symbol for copper. We have F.silk for the front silk screen, F.mask for the front mask, and we have the same for the back. So B copper, B silk, B mask. We have one more layer that we use, which is called the edge cuts. This is the board outline, and this is where the CNC process takes over to give us whatever shape we want that PCB to be. So you will design that outline, that will go into the edge cut. By default, the silk screen will go over the entire board outline. So if you're wanting to take things out, you don't need to actually have kind of a duplicate of the edge cut layer on the front silk or on the front solder mask, because the solder mask is kind of an inclusive process. You automatically get that over the entire board. I'll show you that too. So assuming that the demo gods are not mad at us today, we're going to jump right in to this process. So I have some artwork that was done for SecKC for the 10-year anniversary. There was a challenge coin that was done, and this is what it is. And I have got that in Inkscape, and here are kind of all of the elements that are part of this. So what I'm going to do is go to extensions, and I've already got this extension, the SVG2Shenzen extension, installed, and I'm going to prepare document. So this is going to, I'm sorry, I'm going to do a new before I do that. Extensions, SVG2Shenzen, prepare document. So what this extension does is it creates layers inside of Inkscape. And if you're familiar with vector drawing tools, this is a very common thing. But what it will do is it will name them accordingly to something that KiCAD will be able to import and put them on the appropriate layers inside of the EDA software. So in this case, I'm going to do 100 by 100 millimeters. 100 by 100 millimeters is kind of the sweet spot for PCB manufacturers. So when you go to actually have a board made, kind of the cheapest price is anything 100 millimeters by 100 millimeters or lower. So we're just going to stick with that. And so now if we see over here in the object list, we actually have all of the different layers that we talked about. And so what I'm going to do is pull in the artwork that we've got over here. And if I can get zoom out of the way, we'll paste this in. And so now I have all of the different objects that I need, and all we need to do is get them onto the right layers. So this external line, this is the edge cut. So I'm going to go here, I'm right clicking, going to move to layer, and I'm going to put that on the edge cuts layer. So now that object is still here, but it's over here in the edge cuts layer. We've got this red ring, and this one we actually want to make it copper. So what I'm going to do is I'm going to place this on the copper layer. So I'm going to go to move to layer and move that to front copper. But now here's where we get a little tricky. So remember what I said, that the copper layer is underneath the solder mask. So in order for us to actually see the copper, we actually have to remove it. And so in order to remove the copper, or remove the solder mask so that we could see the copper, as I said, the solder mask layer is a negative. So if I were to take this and duplicate it, which I have another copy right here, and I were to move another copy, the exact same thing, to the front mask layer, what that's going to do is remove the solder mask in that place, and the copper that's underneath will now come through, and we'll be able to actually see that. So we can do the same thing with these stars. So I'm going to take these stars, we're going to move them to the front copper layer. I'm going to grab this other version of the stars and I'm going to move them to the front solder mask layer. And then I'm going to take all this text, so the 10-year and Kansas City's Hacker Hive, and I'm going to place those on the silk screen layer because that I want them to come out white. So we'll put those on front silk and move. And then I've got one more thing, which is this ring right here. I'm going to also keep it white. So I'm going to move it to front silk screen as well. And lastly, we've got Bob. So Bob, I want to do something different. So as I kind of talked about where if we want to have light shine through, and when we get to the electronic side of this, I thought what might be kind of interesting is to actually have some LEDs that light up from the backside to kind of give us some interesting effects. And so what I'm going to actually do is I want to take Bob and I want the FR4 to come through. So we know that there's no copper underneath this because we haven't added any copper. So if I were to put Bob on the front solder mask, it's going to actually remove him from the solder mask. So I'm going to take the first iteration of him and I'm going to move him to the front mask. But I have another copy because in order for the LEDs to shine through on the back side, I actually need to remove Bob from the back solder mask as well. So I'm going to take this instance and I'm going to move him to the back mask. Okay, so now all of our objects really should be set up on the right layers. One other thing that I want to note here is colors. So you'll see that we have in this scenario white and black and red. Whatever colors we use in Inkscape, they really don't matter because, as I said, this is not a full color printing process. The colors that we're going to get are dependent on what silkscreen and solder mask and copper finishes that we select when we go to order the board. So the colors in here don't matter. Whatever we set them to, they're not going to transfer through. That being said, as part of this SVG2Shenzen extension, it does look at colors, and anything that is a dark color, it will export. If it's a lighter color, it looks at that and says that's something that should not be exported, and so it will not send it over. So I try to kind of use different colors to kind of show and remind myself as, you know, what layer these objects are a part of. So in this case, I used red for copper. I've used black for the silk screen. I've used black for the edge cut, which should be black. As a matter of fact, I don't think it will work. The edge cut layer, I think, is one that will only work when it's in black. But that really won't matter once we get it into the tool. So now that we've got this all set up, and that's just so that if you do this with different colors and you find that these layers are not getting brought in, passed through, it might be because you've used too light of a color. So if I go back to SVG2Shenzen, I can go to export to KiCAD, and I'm going to pick a directory. Live demo seems okay. And I'm going to use kind of the defaults. I'm going to export this as a project. We won't talk about that today so much. We'll talk about that in the next talk. Threshold 5 is fine. DPI, this is the dots per inch for the resolution of these objects. 1200 is more than sufficient. And I've got it set to open KiCAD, although whether or not this works, sometimes it doesn't, sometimes it doesn't. So we may have to open this manually. But if I hit apply, it will start the process. And so now what it's doing in the background is it's taking each of these layers and it's actually generating a file that KiCAD can actually understand and import. So it will create a file for the edge cut, for each of the mask and copper layers and the silkscreen layers. And actually, wouldn't you know, it actually did pull this up. But I think we maybe, oh, no, we did it. I did it right. Some reason here, for some reason it's not showing up here. I'm gonna cheat just a little bit. I already had a version of this prepared. So this is what it should come up as. Oh, I remember, I know what happened here. So this was a bug actually in the SVG2Shenzen export that I spent way too many hours hunting down. If you have not saved the document, even though you've given it a directory to export, it goes into a temporary directory. So actually, if I go back here and I just save this version, let me go back here and I'll just call it demo.svg. If I go back and re-export this, give it just a second. Of course, live demo. If I go back now into this one and open this project, this should pop back up. Yep, there we go. Yeah, so this was a bug. It's pretty straightforward to follow. But if you look here, all of those layers, this is KiCAD. These are all of the layers that we saw earlier. And one of the neat things about KiCAD is it actually has a 3D viewer. So if we go to View and 3D Viewer, it will actually render a 3D version of what this should look like. So in this case, I've actually, in the 3D viewer, I've said, I want a black solder mask, I want to use white silk screen, and I want a gold finish for my copper. So what it will do is this color here, this is what the FR4 would look like, because remember, we removed Bob from the solder mask, so we're just seeing all the way through to the FR4. We can see the copper, so that's also been cut out of the solder mask, and the solder or the copper has actually been laid down on the FR4 so that it can shine through. And then the solder mask is where we did not have things cut out from, comes back through, and we have the white silk screen here. If I were to actually rotate this around, you can actually see, because we placed another copy of Bob on the back. So now if we were to have some LEDs on the back of this, the light will actually shine through. So this will give us, the platform that we need for kind of the next version, to be able to put some electronics on this and actually bring this badge to life. I'll jump back over to the slides. We're going to jump past some slides here. So the next step is to actually order this. So you can pick a board manufacturer, a fab house, to actually generate and create your PCB for you. We have used pretty much all of these board manufacturers in the past. We do use PCBWay quite often, and have for a majority of our production badges. But once you've selected the board manufacturer, you'll upload the Gerbers, select your solder mask, silkscreen, and copper finishes, and then order the badges. And sometime within 1 to 1.5 weeks, typically, that PCB will show up, at your door. this is kind of what it looks like when you're ordering the PCB. You select how many designs, in this case is just one, how big the PCB is. I would need to go back and actually select, we had a 100 by 100 work area, but we would, if I look at the actual edge cut layer here in Inkscape, I can see that it's 44 millimeters by 44 millimeters. So if I was ordering this, I would put 44 by 44 in this size. By default, most board houses will give you somewhere between 3 and 5 copies of that board. We're going to use the FR4s as the core, as we kind of discussed, but there are some other options, such as aluminum. So there are some kind of exotic materials that you can also use. Here you'll select your solder mask color. As you can see, as I said earlier, we're using a black solder mask with a white silk screen. And our only options, as a matter of fact, if I try to do black on black, it's not actually going to allow me to do that. I think this was a bug when I was clicking around. But you could select some of these solder mask colors, and there's an advanced button with the PCB way where it will actually open up some additional solder mask and silkscreen colors for you. And then, as I said, for the copper, there are several different options. The cheapest, when you're just prototyping something, and if you're not too concerned with lead, this is the cheapest option. Generally, when we're ordering badges, we either use the hassle lead-free, just from a safety perspective, or we use the immersion gold, which gives us kind of that gold finish for the copper layer. There's also this none or plain copper, which kind of gives you a brightish copper color as well. That being said, what's next? I'm really hoping that this has shown you that while there is a little bit to this, it's really not that complicated. It's really more about getting your artwork designed and then getting it pulled into the tool. And with these tools, with Inkscape and the SVG2Shenzen extension, this can be incredibly easy to do. If you decide you want to attempt this and you run into any problems, you can find us on Discord. If you are all on the SecKC Discord, right? If not, go over to sekkc.org. There's a link to the SecKC Discord. On there, we hang out in the Badge Life channel on Discord. So if you get in there and you run into any problems, feel free to submit your questions there. I don't know what's okay. There we go. Thanks for your time. I'm Carl Fugate. You can find me on Twitter at Carl Fugate, Badge Pirates at Badge Pirates on Twitter. I'm at networkgeek on Discord. And I've got some links to these tools. We'll get these slides posted and get a link out. We're also going to post the files when we get this, as we go through this series. I'll get the artwork. It will be up on GitHub. And then once we get do the electronic design version, those files will also be available on GitHub. Thank you. Any questions coming in?
I saw a lot of discussion in the main general Discord channel, so you might want to check that for any follow-ups. I think everything that Badge Pirates have done, even the earlier works have been fantastic. So, hey, it's awesome.
Thanks, Joel. Yeah, it's been a fun ride. We really never expected to be at this point where we get to have fun doing learning new stuff and having people come up to us like that. It's really kind of a weird thing.
Yeah, the unofficial DEF CON badge is absolutely legendary. One of my friends in Florida who's actually tuned in now is like, dude, you got to tune in. But he bought one. He found it online and somebody was selling one, and he bought one. I think actually it was one that you guys put up on sale. He's like, I have to have it. He hadn't heard of SecKC. He's just like, I have to have this. So yeah, it's legendary.
Yeah, I mean that's what's really great about SecKC is there's so many people with such diverse backgrounds and interests, and being able to to collaborate with other hackers. I mean, what more could you ask for?
There's a question here from Raid in the SecKC channel asking for citations for the most common number of layers statistic.
Yeah. I think it's down here. Yeah, I got it. I just pulled that out. I feel like that's probably the right answer, but thanks for fact checking on that.
Axon, going back to him buying a SecKC badge, I mean, the LEDs on that are worth like 10 grand alone.
Okay, look, I gotta call out. I gotta give a shout out here. So this photo that Codex Mafia has in his background. So this was taken by Jurist, and it is like one of my favorite pictures like ever. To just kind of see where the light's kind of coming through, and it gives you really shows kind of the electronic paths on this board. We've again, whether even when you're for people who are not designing the boards, the people at SecKC who just take pictures of this stuff are incredible as well. Yes, absolutely, Reed. Actually, I think that's probably closer to 90%. Okay. Yeah. If any other questions, come up, come hang out with us in the Badge Life channel on Discord. We love, as you can see, talking about badges. We definitely want to encourage, more people to jump in and do this stuff, because we know that there's a lot of creativity in the SecKC community, and we want to see you guys make more cool shit too.
I think the want is an understatement. We need to see your guys' cool side. Make some cool shit.
All right. Any other questions?
Bueller.
Also, hi, Codex.
Hey, Kayla. I guarantee there's going to be some young viewers out there who don't understand what that reference is, and I'm going to be excited about it.
Hey, at least none of us have a case of a Mondays.
That's right. A good part of being on Tuesdays.
It is.
Network Geek, I think you're muted. I don't know if you're trying to talk or not. I think you have a case of the technologies.
I do. If I could get a kid, to come show me how to do that stuff.
That could be arranged. I might know a person.
Yeah, there's a couple questions here. Are you still selling that badge?
So
and then there's a question on lead times and lag times due to COVID?
Oh, okay. So answering the first question first, yes, I do believe I'm staring at a box or a small quantity of those badges that are available. And so if you are interested, please reach out to FG or myself. We'll figure out how to get you one. Supply chain. I don't know if Aaron can bring his supply chain slide back up. But yeah, supply chain is pretty interesting right now. For anybody who went to B-Sides AC, the badge this year was not the badge that we originally designed. And the reason for that was supply chain. I think a lot of people have heard that the silicon fabs are really hard hit with backlog right now. And all of the integrated circuits that we need to build badges, a lot of the components and really strange things like power regulators are unavailable. It's really, really strange. And I think what we've also seen is a lot of companies, because they couldn't get the parts that they would typically use, I think a lot of companies have started digging into what I would kind of consider the hobbyist parts, and started buying them up as well, just to be able to continue to manufacture things. So absolutely, there is a problem. However, with one exception, PCBs themselves, no delay. There, as a matter of fact, I feel like they're getting them out as quick, if not even a little bit faster sometimes now than they were. Mainly because I think they don't have as much assembly because the components aren't available. So if you just want the artistic side of these things, you can absolutely get them as fast as normal. But if you are looking to do the electronic side, be careful, because if you're designing something and you're using a component, by the time you order the board, the components may not be available. So I highly recommend pre-buying components ahead of actually having the PCB, because they may not be there by the time you need them.
There's a question also on your experiences with SMT and soldering.
I would love to let Rickson take that question. So Rickson, I want to just a little caveat to that. So the very first prototype there was really only one, I believe, prototype that was actually assembled for the DC27 badge. 648 LEDs, Rickson hand soldered that thing. I think he will never do anything like that again because of it. So we actually had the production run made by PCB. So they have pick and place machines, and they did that. The LED boards, they assembled those for us. We just did the control board. So that badge was actually two PCBs that used a connector to go together. We did all the SMD components on the controller boards, and it can be challenging. Not all SMD components are created equal. Some are, relatively easy to hand solder. Others require a microscope and really fine chiseled soldering irons to be able to do, and steady hands. So it certainly depends. But I definitely, I think SMD gets a bad rap, but at the hobbyist scale, unless you're, trying to work on like a board out of a phone or something, of that nature, the components generally aren't too bad to be able to do by hand. It certainly takes some practice. There are some, I will pimp out AliExpress a little bit here. There's a lot of kind of soldering kits available for really, really cheap. that are practice solder kits on AliExpress, including surface mount, and they send you a PCB with a bunch of different size SMD components. They are perfect for getting your hands trained for working on SMD stuff, and you don't have to worry about messing anything up.
Do you have any favorite badges that, aside from the one with the zillion LEDs? That,
okay, well, I have one. I'm going to pull it down. So this is near and dear to my heart. It's the very first Bender badge. This is, for me, this is what started badge life for me. This was the very first unofficial badge at DEF CON that I got. I was extremely lucky because the very first Bender badges, they only made, it was very small, only a couple of hundred, I think, if that. And so this is by far my favorite because I would not be doing badge life and badge pirates had it not been for this badge.
let's see here.
Fair warning, if you go the AliExpress route for getting badges, it's going to be probably about 2 months before you get them. So order in bulk.
And shout out to Jigglebilly for doing a lot of helping with a Q&A on Discord.
So there's a question here. Where do you get your inspiration for badge designs?
Memes. For sure, and I think Jigglebilly is definitely our meme master in the badge pirate team. Man, that's a great question. I think it really depends on the badge. Rickson was conceived and designed the DC-27 badge. The DC-26 badge that we did was kind of an evolution. It was really getting to actually really doing artwork on a PCB. It took a lot of elements from the DC-25 badge. For conference badges, we try to look at the themes that the conferences have, but that doesn't always translate into what we do with the badges. But we just kind of brainstorm, and that's what's nice about having a team, right? Because everybody just kind of throws out ideas, and we kind of kick them around and put them in a blender and come up with something. And it's nice that we've been fortunate to come up with some neat designs over the last couple of years.
Reed asks, so will there be a DEF CON 30 badge?
Will there be a DEF CON 30?
Will there be DEF CON?
I heard it's canceled.
I don't know. Someone should probably check in on that, let us know.
Yeah. Again, I think, to Jigglebilly's point, we assuming there's no supply chain problem and we can get going pretty soon. I think we've got an idea for one.
I'm waiting for DEF CON to make their official badge a Rickroll saying it. I mean, it's just picture Rick Astley and it says canceled in the top right or something. That'd be so them.
Oh.
Oh, I see it now. Hey, Potterface badge.
Absolutely.
I love it. If nothing else, that needs to be an SAO.
Yeah, absolutely. So Dan, I want to see you. I want to see you do that.
I want to see a Rick Astley SAO too. Somebody out there better make one.
Yeah. So Savage, I like that. And if somewhere we actually may have something similar to that. that's been done and was supposed to be a product like 2 years ago, but we'll see.
We'll see.
Yeah, the downside to getting into badges is it's a gateway drug to more badges. So once you do one thing, you just it's a rabbit hole that you just fall down and end up with all sorts of different ideas coming to life.
Exhibit A, that board of badges behind Network Geek, I help him hang it, and that didn't exist like a year ago.
Yeah, and that's not even close to like all the badges.
Oh no.
We don't even have half the conferences up there. Like this is, sneak peek. This is another project that's in the works as well. So if you're looking, if you got a bunch of SAOs, be on the lookout. This may be coming to a conference near you sometime.
Probably not.
Maybe.
It's canceled. SAOs are canceled. But fuck $5.
All the badges, yes.
All the badges. Fuck $5. I'm down with it.
Oh yeah, well actually we need to do call for party badge, right? So that being said, I mean, if is there a SecKC party this year? If there is, maybe a call for party badges. If anybody's wanting to jump in and do something interesting for that. Always looking for collaborators, or
only if it's if everybody is given a full size human gerbil ball to mingle with people with.
That's going to be the badge, Joel. It's just going to say badge on the front somewhere, and then there you go.
So let's see here.
Did you really just look up that scene from Moneyball?
I was actually trying to create a GIF of this earlier. I don't know why I didn't think of it earlier. I wanted to actually make a GIF of this, and I'll probably tweet it out here later. But yeah, it's definitely Badge Life is definitely that scene from Moneyball.
OPSEC. OPSEC.com. Frogman, I need an email address to that. Hackerman at opsec.com. Ope.
I guess I need to pay my Discord money so I can use the SecKC emojis.
No, you can use them.
No, it won't let me.
Look at that. Look at that.
Yeah, you can. I can't.
You should be able to. What chat are you trying to use?
No, you can't. You've got to be one of the boosters to use the fancy emojis.
Yeah, that's
how they get you, dude.
In the server?
Yes, in the
Since
server.
when?
Since quite a while ago.
Oh, man.
I actually have memes about this too. Like Bethesda is pay to lose, et cetera, and Discord Discord is pay to use custom emojis. Yeah.
You just get them on PCBs, put all of our emojis on SAOs, and then pay to use SAOs now.
So Dan asked about the QR code SAO. I don't know. I don't know if anybody's done just an SAO. I'm thinking that somebody did, but but there's always room for more QR code SAOs.
Yeah, I saw one where somebody had put a sticker of a QR code over a badge.
Yep.
But I haven't seen like a proper SAO before.
So there you go, Dan. That's yours. Do it. And if
do it, and I'll fuck $5. I don't care.
If it's not a Rickroll link, you're doing it wrong.
If it's not a SecKC link, you're doing it wrong. Or a badge pirate link.
Well, this has been awesome. I appreciate all the interactions. Seems like people kind of like badges and are interested in this, and I hope this has demystified badges. It really the tool sets these days really do make this a lot easier than it used to be, for sure.
That was a great talk.
Agreed.
Yeah, it really was.
Man, he gave away all of our secret sauce, though.
Yeah.
I don't know how the bad parts are going to survive after this.
Yeah. We weren't profiting before. I don't expect it's going to change our financial position.
Yeah. Well, unless we have any more shenanigans or cool stuff to talk about, I think that is our last talk of the day.
It is, and we managed to use up all the time almost to 9:30 anyways.
Sweet.
Excellently. Well done.
I'm glad I went last to go over.
No, that was fantastic. Thank you. And Joel, yours as well.
Yeah.
Learned a lot from both of them.
I really was, Joel, I was really waiting for you to jump in and do live commentary.
Yeah.
I was so disappointed to not get the live commentary. The editor,
the editing on editing. I'll remember that next time.
We'll call it director's comments.
The director, yeah, the
director's cut.
I was looking for the director's commentary to go,
or the director's commentary. The movie executives, commentary on the commentary of the show. So
and then you can stream that.
Hilarious. They do a drinking game out of it, and they get so drunk in about the first 20 minutes that nobody talks for like the next hour. It's hilarious.
Where's the fun in that? You actually can hear the talk at that point. Versus drunk shenanigans.
Yeah. Alrighty.
Well, thanks all for a wonderful SecKC. This was fun.
Yes.
January.
It was fun.
Thank you to both of our wonderful speakers.
Yep.
And Kayla and Aaron for 101 and news.
Yeah.
Anytime.
And this show has been brought to you by Log4j.
My depression has been brought to you by Log4j.
My lack of sleep was brought to you by
also by Nodos and
Log4j.
And lots
or
of
when you
caffeine,
think life
lots
is
of
going well, Log4j.
All right. Well, see you later.
Later on.
Peace.
And we're out.
That was a good take.
Yeah.
That was a good meeting.
That was a good meeting.